Hello class, welcome to lesson 1111, which is all about inverse variation. By the end of this lesson, you should be able to identify and use inverse variations, as well as be able to graph inverse variations. Okay, so at the beginning of the year, we talked about direct variation, which, if you remember, was the form y equals kx, where k was just a constant number. And this was our direct variation. But now, today, we are going to talk about something called inverse variation. Inverse variation can be written as y equals k over x, or more commonly, xy equals k, where x cannot equal 0 and y cannot equal 0. So let's look at an example where we're trying to determine whether the information we're given represents an inverse or direct variation, and we need to explain. So if we look at this first one, we have x equals 1, y equals 10, x equals 2, y equals 5, x equals 5, y equals 2. Well, remember, direct variation is y equals kx, or inverse, we just said, was xy equals k, or y equals k over x. Well, in this instance, we have an x and a y, so let's try to see if it matches this. So that means if I take my x and I multiply by my y, 1 times 10 gives me 10, and then if I take the next one, 2 times 5, if it's inverse variation, I should get the same number. So 2 times 5, that gives me 10, or 5 times 2, also 10. So that means this is inverse variation. Let's take a look at our next one. We have negative 2x equals y. Okay, so we have a constant times x equals y. This is looking a little familiar. It's looking like it's already set up in one of these forms. If I look over at my direct variation, y equals a number times x. Oh look, I have y equals a number times x. So that means that this is direct variation. Okay, so you're going to be able to, you should be able to identify if something's inverse or direct variation. I want you to take a minute, look at this table, and see if you can determine if it's inverse or direct variation. Alright, hopefully when you looked at it, you noticed that if you multiply 1 times 20, you get 20, 2 times 10, 20, 4 times 5 is 20. That means, since all those numbers end up multiplying to the same thing, we have an inverse variation. Let's take a look at our second example. We want to assume that y varies inversely as x. Okay, so we're assuming it's an inverse variation. If y equals 5 and if y equals 5 when x equals negative 4, write an inverse variation equation that relates x and y. So remember, our inverse variation can be, oops, sorry, I took 20 from the last slide, can be written as xy equals k, where k is a constant number. So now, if we look here, we know when y equals 5, x equals negative 4, and if we multiply those together, we get negative 20. So that means our k value is negative 20. So now we have our k value, and in order to write an inverse variation equation, we just have to plug this information in up here. So we have xy equals negative 20, or if you prefer to write it in the other way where y is by itself, you can move your x over and say y equals negative 20 divided by x. Both of these answers are correct, okay? You can write it either way. Why don't you guys take a minute and see if you can figure out which inverse variation equation correctly demonstrates this problem. Alright, hopefully you ended up with letter C. If not, please be sure to make a note and ask me in class tomorrow or ask a friend. Or you can always rewind the video and watch the last example again to see if you can figure this one out. Let's look at another key concept. There's a thing called the product rule for inverse variations. If we know that 2 points are, or 2 sets of numbers are solutions of an inverse variation, then the products are equal. So that means if I take x1 times y1, it should equal x2 times y2. Or it can always be x1 divided by x2 over y2 divided by y1. Notice that the 1's alternate when you do the division, and the 2's alternate, okay? They're diagonal from each other, not on the same level. So let's take a look at example 3. If y varies inversely as x and y equals 4 when y equals -8, find y when x equals -4. Okay? The wording might seem a little bit confusing, but it might help to group your numbers together, okay? Kind of like they were on the last slide. So we know when x equals -8, y equals 4, and then we want to find y, so I'm just going to say y, when x equals -4. Excuse me. We know from our product rule that x1, y1 equals x2, y2. So if I plug in this information, my x1, I have a -8. My y1, I have a 4. So -8 times 4 should equal, and then our x2, -4 times y. Back on the left-hand side of my equation, I have -8 times 4, that's -32, equals -4y. Get y by itself, I divide both sides by -4, and I'm left with 8 equals y as my answer. So I found y to equal 8. Alright, why don't you guys try this problem on your own? Separate them into 2 maybe ordered pairs and try setting up your equation. Alright, hopefully you ended up with letter C. If not, please be sure to ask either myself or a friend, or rewind the video and watch that example again. Let's take a look at example 4. Manuel runs an average of 8 miles per hour and finishes a race in 0.39 hours. Dani finished the race in 0.035 hours. What was her average pace? Okay, so Manuel, 8 miles, and then in 0.39 hours, and Dani, we know, was 0.35 hours, and we want to know what her average pace was. So we want to know what her miles per hour. So I'm going to do green for Dani and blue for Manuel. The information I know about Manuel is that he has 8 miles per hour, 0.39 hours. And then Dani, I know, 0.35. And then I want to know how fast she goes. I'm just going to use M for miles per hour. What I can do, I can say 8 times 0.39, and then I can move this over by dividing. So if I do 8 times 0.39 divided by 0.35, I'm left with about 8.9 miles per hour. Okay? Now that makes sense because if you look at the times, Dani finished faster in less time than Manuel did. So the fact that she did 0.9 miles per hour faster than Manuel makes sense. Remember to always think about how realistic your answer is. Why don't you guys take a minute and look at this example, see if you can solve it. Alright, hopefully you ended up with letter D. If you got a different answer, please be sure to let me know. Ask questions, ask for help. I'm more than happy to help. And our last example. Graph an inverse variation equation in which y equals 16 when x equals 4. Okay, so first we know y equals 16 when x equals 4. So let's write our equation so we can graph it. Inverse variation, xy equals k. So if we do 4 times 16, we are left with 64 as our k. That means xy equals 64. And if we solve for y, this becomes y equals 64 over x. So now we can make our xy table. Actually, let's pull this down. All right, I'm going to make an xy table. If I plug, what are some good numbers to divide 64 by? If I want to do both some negatives and positives. So I'm going to start with a -4, because if I do a -4, I'm going to get an even number. I'm going to get a -16, but you know, it's still there. If I do a -2, that should go in there nicely. It's a -32. If I do a -8, it's another number that goes into 64. I get a -8 out. Okay, so I have a few options here. I can go, if I adjust my scale, I can say that these are going by 2's in the x direction. So -2, -4, -6. Or actually, we can leave the x factor, or x scale alone. So this can be -2, -4, -6, -8. Because x values, that was the smallest one I plugged in. But y values, I have to get all the way up to a 32. So why don't I count by, let's go by 4's. So -4, -8, -12, 16, 20, 24, 28, 32, 36, and 40. Okay, so if I plot these points, -8, 8 is one of them. -8, -8, -4, 6, -16, and -2, -32. So as you can see, it kind of does a curve like this. And then if I plug in some positive numbers, if I plug in those same numbers but positive, so if I do a 2, and then 4, 8, these are all going to be the same number, but they should be opposite signs. So instead of a -32, I should get +32. 4, I should get +16, and then a +8. So I'm going to do the same thing over here. I'm going to go by 4's. 4, 8, 12, 16, 20. Oops. It is sliding over. 24, 28, 32. That's as high as I need to go that way. Scroll down again so we can see. So then if I go 2, I know I need to go up to 32. And then 4 is up at 16, and 8 is at 8. So you can see again that our graph goes like this. So something you'll notice about inverse variation is that they look a little funny. They're going to curve away from each other and usually be in, or they're going to be in different quadrants is what you're going to deal with. All right, why don't you guys take a moment and see which of these graphs matches the inverse variation in which y equals 8 when x equals 3. Okay, hopefully you ended up with letter B. If not, be sure to ask, and I'd be more than happy to help. Okay, a quick overview of the types of graphs we've looked at this year. Direct variation is our y equals kx. Y equals kx, you know, just depends on if it's positive or negative. And here's some criteria about direct variation. And then on the right-hand side of the screen, to help you keep it straight, we have what inverse variation looks like when k is positive or when k is negative. And then some common criteria about inverse variation. So that's some good stuff to write down in your notes. That is the last bit for 11:11. If you have any questions, be sure to ask because I don't know what you don't know, okay? You need to express any questions or concerns you have. All right, I hope you guys have a fantastic night. See you tomorrow.